Take it away.
Thank you. Hey guys, I'm Kalpana Arivazhagan. I'm a full stack software engineer with Capital One. For the past couple of years, I've been focusing on front-end development with technologies like AngularJs and Node. Most recently, I've been working with React applications. And this is not going to be a working presentation, so if you guys choose to, you can put away your laptops. And if you have any questions regarding the presentation, you can take a note of them, and towards the end, we'll have plenty of time to go over them. So let's get started. So here, we're going to try and understand what is React state. So I'm going to go right out and say that state is nothing but data. So we're going to understand how data is being managed in a React application. So what is React, first of all? React is a JavaScript library that is used to build user interfaces. And the building block of a React application is a component. And this is a very simplified representation of a component. So what a component does is it gets some data, it does some manipulation, and it's going to show something onto the user interface. So how does a component get access to this data? It does so via props and state. So what is props? So whenever a component is being instantiated for the first time, it gets some properties from its parent or from external sources. And that is typically available to every component in an object called props, which is nothing but key value properties. And sometimes the components might choose to store some information about themselves in a place called state. And they're also referred to as local state or component state. So we know that props and state are the two ways in which a component can access data. And using these two, the component is going to do some manipulation, and it's going to produce UI elements. Now, the important thing that we have to keep in mind is, since props is going to be coming from external sources, the component shouldn't try to manipulate that. So we don't own a particular piece of data, so we shouldn't be trying to mutate that data. So always keep in mind that props is immutable and treated as a read-only object. So trying to do something like this, assigning a value to an attribute that is coming from props is illegal in React application. On the other hand, change something to your local state, which is your component state, then that is possible. Because component is storing some information about itself, and since component knows what it's doing, and it knows exactly how to manage that data, it makes more sense if you can mutate that data. So the right way to mutate a component state is by calling the setState method of React API. And while we're on the topic of components, in React, we can generally classify components into two types. One is presentational, and the other one is container components. First, we're going to try and understand what a presentational component is. So from the name, you can probably tell that these components are mostly interested about how things look on the user interface. And by that, we mean they're going to be independent and isolated components. And if you give them a data, they're going to process it, and they're going to show something onto the UI. That's all. If you look at them from an entire application perspective, they're not going to have much information about the application itself. Some people like to call them dumb components, but that is probably not the right word to call them. They serve a very important purpose in a React application as well. So generally, we have two flavors of presentational components. One is stateless, and the other one is stateful. Again, from the name, you can probably tell that the only difference between these two is that one is going to maintain its own component state, whereas the other one is not going to have any component state. So stateless presentational components are also known as functional components. They rely solely on the properties that they're going to get from the external source or their parent component to render something onto the user interface. Whereas stateful, on the other hand, in addition to the properties that they get from the parent, they're also going to maintain some local state. So let's look at an example. So here we have a simple component called greetings, and we have a render function. So someone who is new to React might wonder what this function is doing. So this render function is the function that is used to render something onto the user interface. So whenever you want to use the greetings component, that component is going to say a message to the user interface, which is hello. And it uses the name attribute that it gets from the properties to display that message. And this is a very simple component. There's no state involved here. Whereas in a stateful component, you can see that there is a lot more stuff going on. So we have a component called form. And during instantiation of this component, we are setting an attribute called name to an empty string, and we are storing that to our state information. So this means that this component has its own local state. And if you look at the render function itself, we have a simple text box, and we are listening to the onChange event of the browser. So whenever the user enters something onto the text box, we're going to trigger this onChange event, and that in turn is going to call the update state function. And what that update state function does is, it has a call to set state. So from the previous slide, we know that set state is used to set the component state or to mutate the component state. So here what we are doing is, we access the latest value from the text box, and we assign that to our local state variable called name. And whenever you call set state, React knows that it has to update the component state. And what happens when it updates the component state is that it's going to go and check your render function to see if this particular state that you're updating is being used in your render function. So in our case, we only have one state variable called name. And if you look at our render function, we are using that over here at the very last line, this.state.name. So when the set state function is being called, after updating the component state, React knows that it has to re-render the component in order to show the latest value. So it calls the render function again. And when it comes here, we have the latest value, and that is going to be passed to this new component called greetings. So I want you to focus on the second line now. So from the left-hand side, we know that greetings component itself is a presentational component, and that is expecting to receive a property called name from its parent. And here, we are actually passing that name property, and the value itself is going to be our state value. And this is how the latest value from the parent will be passed down to the greetings component. And since greetings itself is using that in its render function, it knows that it has to re-render itself. Re-rendering, I keep saying that, so what does it mean? It means that we have to refresh the component and show the latest content onto the UI. So now that we know what a presentational component is, we're going to dig deeper into stateful presentational component, because end of the day, we want to understand how to manage data in a component, right? I want to talk to you about a couple scenarios in which it might make more sense to use a component state, whereas in some situations, it might be an overkill. So the first point that is very important for us to remember is, whenever you get something from your properties, that is from your parent or from any other external source, you have to think and see if there is a way in which you can directly use that props in your render function. By that, I mean, let's look at this example. So we have a component called name, and the goal of this component is to say hello again. And during instantiation of this component, we are expecting the first name and the last name from the properties. We are using those two properties, and we are computing the full name and storing it to a variable called full name on our state. And in the render function itself, we are saying hello, and we are using the state full name that we just created. So what's wrong with this approach is, at the very first time when we instantiate this component, we get the full name computed, and we are going to render the right full name, and we're going to say hello full name. That's OK. But what happens to the subsequent updates that happens to the first name and last name? So because we are not using the props directly in our render function, we are going to lose those updates. Every time the first name and last name changes, it's going to come to name component, but we are not going to be using that in our render function. So this component is never going to say an updated hello message. So the rather more right approach in this case would be to do something like this. Here, if you see, we don't have any component state at all. It's a simple render function. And instead of trying to store something on our component state, we are computing the full name directly on our render function by using the props first name and props last name. So this might be one of the common situations that we encounter frequently in React applications. And most of the times, when a component is expecting something from its parent, we want to re-render that component. So this way, we make sure that we never lose those updates. And also, we are not duplicating any information onto our state when we can simply use them directly in our render function. And one of the other important scenarios that we have to keep in mind is it's good to mutate state. It's good to change the state that we have in our components. But there are certain places where we have to be more cautious and rather not try to use set state. So one of the functions that we avoid using set state is render function. So here we have a simple component called time. The goal of the time component is to show the latest time whenever it's being rendered. So what we are trying to do here is we are instantiating this component. And while we're instantiating it, we are creating a name called, we are creating an attribute called current time on our state. And we are setting it to null. And while we are rendering it, we are trying to set the state, which is current time to whatever time at that moment was. So from our previous slides, we have learned that whenever we call set state, it's going to update the component state. And it's going to check and see if that attribute is being used in the render function. So in our case, this .state.currentTime is being used here. So the render function will be called whenever you call set state. So we come here, we call set state, we update the state, we come back to render function. And when we come back, we again have a set state. You can see that where I'm going with this. This results in an infinite loop. React doesn't go beyond this line. It keeps trying to update the state and keeps trying to re-render the component. So to avoid this, we can do something like this. And again, there's a lot of ways to solve this problem. This is one of the approaches that I chose to do for this presentation. The only difference that is there in this, on the right side of this presentation is I've removed the set state from my render function itself. And in turn, I've moved this current time, setting it to new date, to my constructor. So what this is going to achieve is, whenever my time component is being rendered for the first time, I'm going to make sure that I have the latest time because I'm doing it in the constructor. And afterwards, I'm controlling when I'm going to update my current time. So if you look at the render function, we have a button called show time. So whenever a user clicks on this show time button, I'm having an on-click event listener. And this on-click is going to call the update time function, which is this one. And this one is going to make a call to the set state, which is going to update the current time. And we have gone through this exercise before, so we know that it's going to update the state, and it's going to come back to render function. And here, we have the updated current time information available. This way, we can avoid going into an infinite loop situation. And now we understand that this is a bad practice, and we shouldn't be doing this. But there are some situations when you're working with React applications which might not be that straightforward. For example, there are some internal React lifecycle methods where if you try to mutate your state, you could probably run into trickier situations like this. And one of the examples is component did update. OK, so we've covered a lot. Now we know what a React component is. We know how a component can access data via props and state. We've seen what a presentational component is and what are the two flavors. One is stateless and the other one is stateful. And what might be a better situation in which we can use a component state, whereas in some situations it's better to avoid that altogether. And we've also seen how props get passed down from a parent to child. Next, we're going to try and learn more about the container components. So what is this? From presentational components, we know that they only care about UI and they don't know the big picture. These are the big guys. Container components know more about the application than the presentational components. In other words, they maintain the state of the application itself. So what do we mean by application state? We already know that state is nothing but data, and application is our application itself. So container components has a global view of what the application does, and it maintains the global information. You can think of this data as a data that you want to persist throughout the life cycle of your application. So since container components manage this data, it has access to them, and it can trickle down that information to any of the child components that might need them. And since container component itself is a component by itself, since container component itself is a React component, it could have a lot of child components. And the child component themselves might be a container component, in which case they'll also be connected to the application state. Or they could be simple presentational component who have no idea what an application state is. Now we know what an application state is, and now we know what a component state is. I think it's important for us to also understand how do we manage this application state. Probably if you're doing some getting started with React application, yeah, some to-do applications just to get started with React, then you might not need to use application state manager. But those who are trying to work with React applications in an enterprise level, which is much more complicated and you have to handle a lot more complex data flows, it might be a good practice to involve application state management, especially the external ones. So to understand this, I think we have to take a step back and look at the evolution of single-page applications itself. So in the past, there have been several technologies that came up with their own way of managing the application state. And one such example is Backbone.js. Backbone.js was a pioneer in single-page application. It was a simple and well-received framework. The documentation is pretty good. Even today, we have several applications that are using Backbone.js framework. They introduced a concept called database for front-end. And that is very similar to what we have for the backend, like relational databases. And they chose to do this database design by using something called collections and models. And they closely resembled tables and rows concept that we have in relational database. And it worked pretty well for the time being, but then we kept evolving. JavaScript has evolved so much in the past couple of years. And then React came along. When Facebook introduced React, they also came up with a pattern called Flux. And Flux was a kind of like a new way of managing the application state for applications. And we're going to take a closer look at the Flux architecture itself. You might be familiar with some of the entities here. Let me clarify what they mean in terms of Flux architecture. We're going to get started with action. So what is an action? Action is a simple object with a type attribute. And an action typically conveys what the user intent is. And dispatcher is a simple mechanism by which we let the stores know that an action is pending, and you have to somehow update yourself so that the state can be mutated. And what is a store? So store is kind of like a placeholder where you store your application data. And it is also the place where you put your logic to mutate your data. So it has the data and the logic to change the data as well. And as you can see, we can have multiple stores in Flux architecture. And the view finally could be any UI view library that you're using. It could be AngularJS, it could be React, Ember, whatever you choose to use. And if you look at the flow itself, whenever the UI or the view wants to make changes to the application data, it's going to dispatch an action. And the dispatcher, upon receiving this, is going to let the stores know that, hey, an action is pending. So if you're interested, you can change the data somehow. And the stores who are interested in making changes for that action type is going to mutate the data somehow. And they're going to let the views know that the application state has changed. Probably you might have to re-render yourself. And the view, imagine if it were a React component, what it's going to do is, upon receiving this new information from the store, it's going to update itself. And it is also going to let all the child components know that the data has changed. So probably you have to re-render yourself. And this is what happens with the typical Flux architecture, and this feedback mechanism loop goes on and on. So this is pretty well received. We have several implementations. Some of the examples could be Reflux, Alt, and several other implementations. But one of the problems that arise with Flux architecture is the concept of having multiple stores. So this particular thing could become problematic in situations where you have a very complex enterprise application, and your data flows is pretty complicated. So what could happen is, you have a bug in your application, and you're trying to debug it. You want to know exactly what action was triggered, and in which part of the store mutated the data. But because you have multiple stores, and more than one store could be touching and changing the same part of your application data, it is very difficult to pinpoint exactly how the data got changed or which part of the store changed the data. And on the other hand, because there are multiple stores and the views are all subscribed to the stores, keeping the store, that is the data in the store, and the view components in sync is pretty challenging because there might be a subset of view components that are subscribed to store 1, and the subset of components that is subscribed to store n might be altogether different. But you still have to manage those relationships somehow, and sometimes it causes a lot more re-rendering, and it could affect your performance. Thankfully, almost at the same time as Flux was introduced, someone else was working on something more simpler and awesome, like Redux. And as you can probably see from this architecture diagram, many of the entities that we use in a Redux architecture is similar to Flux. Redux is by no means a Flux implementation. It shares the concept of Flux. It takes the ideas, but they came up with their own solution for this. Let's start from action again. So action over here is the exact same concept as Flux. It is a simple object with a type, and the type conveys what the user intent is. And it also has additional information that will let the store know how it has to change the data. And while we are on the Flux topic, I mentioned that, the data lives on the store, and the logic to mutate the data also lives on the store. In Redux, they are going to be split. So the logic that is required to change the data has been moved to a new entity called reducer, and the data alone now lives in the store. And one other important thing that you have to note about store is there's no concept of multiple stores. We only have one single store. And the view, again, could be any view, React.js, AngularJS, you name it. And if we look at the feedback loop, whenever the view wants to dispatch an action, that is, it wants to change the application data somehow, it's going to dispatch an action. And the action has a type. It is going to be forwarded to a reducer. And the reducer, upon seeing the action type, knows how exactly it has to change the data. So it's going to change the data, and it is going to return it to the store. The store will receive the new data, and it will update itself. And it will let all the views that are subscribed to it know that the application state has changed. And view, again, if it were a React view, then it knows that it has to update itself, and it has to let all the child know that the data has changed. And there are several benefits with going to Redux. Like, first of all, there is no concept of multiple stores, so it's very easy to debug. And they also came up with a lot of debugging tools, like time travel debugger and all that, which lets you see exactly how data changed over a period of time, like state A to state B to state C, how exactly it got changed, and what action caused that data to change. And they always assume that the data is immutable. We have concept of one store, and the data is immutable. So whenever you want to change the data, the only way to do is by triggering an action. Now, we're going to see how we can incorporate a Redux application state manager into a React application. As I said earlier, React and Redux is independent. So React can work with any other application state management, and Redux can work with any other view. Because of that, Redux itself is not included as part of the React library. So if you want to use both of them together, we have to use a package called React-redux. And we're going to look at a couple of examples to understand how an action, reducer, and how we put together the store and the component together. First, I want to show you a piece of code that is the action. We have a simple function called add_task. It takes one parameter, description. And all it does is it returns an action. As you can see, it returns a simple object with a type. That's why I call it an action. And the type is very descriptive. It says what exactly the user wants to do. The user wants to add a task to the store. And along with that, we are also passing the additional information, which is description. And description is nothing but the description of the task that the user wants to add to the store. So we saw how an action might look like. Next, we're going to see how a reducer will look like. So this is another function that takes state as the first input, and action as its second parameter. And depending on the type of the action, the reducer has logic to update the data. So here we have an attribute called tasks stored in our application state, and looks like tasks is a list of is an array of tasks itself, and the description that we got from the action is going to be the new task that we're going to add to the existing list of tasks. And since we know that state.concat, like array.concat is always going to return a new array, we're going to do that. We're going to append the new description, and we're going to return a new array back from reducer. And from this diagram, we know that store is expecting to receive the new value from reducer. So we have the action, and we have the reducer. Now we're going to understand how we bring in this updated information into our component itself. So this line that you see here at the bottom, connect, it's a method available on React-redux package. And it takes several parameters. For now, we're just going to focus on the first parameter that it takes. And the last one that you see is the component itself. Assume that there is a React component called to-do. So what this map state to props does. So the idea is you have your state information. You want to bring in that state information into your to-do or your React component. So the only way you can inject something into your component is by props. So the name exactly states that. We want to map the state to the props of this component. So let's take a look at what this function does. It's a function that takes one parameter, which is the state, and it returns an object. And the object itself has a key and value. Key is called tasks, and the value is nothing but the tasks that's stored in our state. And this key that you see here, tasks, this is what is going to be available in our to-do component. So once this statement, this piece of code has been executed, you should be able to do something like this.props.tasks. And voila, you have access to the list of tasks that you have in your store. Next, now that we have the state itself in our component, we're going to see how we can mutate that state in our component. So this piece of code builds on top of the previous one that you just saw. The additional piece of code that's been added here is map action to props and the connect function itself. Now the connect function has two parameters, two inputs. The first one is map state to props, and the next one is map action to props. As the name suggests, we're going to bring in the actions inside the component. And if we look at this function, it takes one parameter, which is dispatch. And again, this returns an object similar to what we had here. And we have a key and value. Key is called addTask, and the value itself is a function, which is going to dispatch an action. Again, like this.props.tasks, now we should have access to this.props.addTask in our to-do component. And we're going to see a bit more code about to-do so that we could better understand how this container component might pass down this information to any of its children. OK, so now we have been connected to the store. We have the data from the store, and we also have the action from the store. So the to-do component has two goals. One goal is to list the tasks that it has in the store, and the second one is letting the user add a new task to the store. So why we want to talk about passing down this information to child components is that the idea is to have fewer container components as much as possible. Because you saw that we had a little bit of boilerplate code that we had in our previous slide, like connecting through the store, and the way we bring in the state and action might actually grow bigger and bigger as your application grows. So we might not want to do that in every component that we have in our application. Typically, applications will have very few container components, and majority of them would be presentational components. So we're going to see how this gets passed down to its child component. Task input, as you can see, gets one property being passed to it. One is add, and the value itself is the add task that we got from the store. That is the action. And the task list is going to have access to all the tasks from the store. We're going to take a closer look at the task input itself. And if you look at the render function, we have a text box again, and we are listening to the onBlur event itself. So whenever the user types something to the text box and leaves the field, the onBlur event gets triggered, and we're going to call the add_tasks_to_store function. And when it comes to this function, we are getting the latest value that is stored in the text box, and we are storing it to a variable called description. And because from our parent, we pass down a property called add, we can make use of that property in our child, which is this.props.add, and we're going to send the description value that we just got from the text box. And finally, we are going to make sure that the text box has been emptied so that the user can go ahead and add another task to the store. So if you look at this, task input is a simple presentational component. It has no idea about the store, but it was still able to make changes to the application data itself because the parent container component was able to pass down the action that the child might need in order to mutate the store. Yeah, so this is my presentation itself, guys. I hope I was able to clarify some of the questions you might have had about React and React state management itself. Feel free to connect with me. I'm on LinkedIn. And if you have any questions, we can go over them now. Thank you.